See? Okay, so first thing I want to do is just recap some of the function stuff that, because it's been a long time since we talked about it. So this is going to be 7 inverse functions. Okay, so let's recall some of our old stuff. Do you remember if I give you a function like f of x equals 2x plus 1, maybe g of x equals, oh, who cares? How about x squared? Let's just do some warm-up stuff. If I ask you to find these couple of things. Try those 4 things real quick. See if you remember what those even mean, what you're doing. We'll go from there. Okay, we got some answers. What would f of 2 be? Just give me the answer. What's the answer there? 5, right? Remember what this notation means. It means go to the f function, right? This one, and plug in a 2 for x. So 2 times 2 is 4 plus 1 is 5. It's just a 5. That's my answer. I'm all done. So when I'm trying to do g of 7, it's the same idea, but now I'm going to go to the g function and I'm going to plug in 7. So my answer to that one is just 49. Easy peasy. Now, this third one is a little weirder because it says f plus g of x. That just means I'm literally going to take the f and g functions and add them together. And in this case, if there's an x there, that means I just don't plug anything in. I just leave it as an x. So all I have to do when I'm adding the 2 functions together is literally just add these 2 functions. So wouldn't that just get me x squared plus 2x plus 1? There's those 2 functions added together. Since that's an x, I'm done. If there had been a number in there instead, let's say maybe there was a 3 in there, then I would go in and I'd plug in a 3 for x and see what I get out. Kind of like what's going on in the last one. The last one's telling me, remember there was a difference between an open dot and a closed dot? The closed dot really means to multiply. So I'm really just multiplying these 2 functions together. Then I'm going to plug in a 1 and see what actually comes out. So let's multiply f and g together. So that would be x squared times 2x plus 1. So if I actually multiply that through, I'm going to get 2x cubed plus x squared. So now I just need to do that part where I plug in the 1. So that just gets me 2 plus 1. I get a 3 in the end, don't I? So there would be my final answer. So does this ring a bell? Do you remember this? Yeah, okay. So now we also, these were operations with functions. Then we also did something called composition of functions, where we took one function and literally put it inside of another one. So let's see if we remember how to do those. So let's try, let's see if you remember how to do this. Do you remember what that meant to do? Someone tell me, what does this notation mean? What am I actually doing? Luke?
That you plug X into G.
Yes. So you're working from the inside out. So on the inside, I have g of x, right? So that is x squared. So what this is now saying is now take this and put that into the f function. So I'm going to take x squared and I'm going to come over to the f function, and instead of, I'm going to swap out wherever I see an x, I'm going to replace it with whatever the g of x function is. So in this case, it's x squared. So when I do that, this one's pretty straightforward because it's just going to become 2, and then instead of writing x, I replace it with whatever the g of x function is. In this case, it's just x squared, and then plus 1. If you remember, there was 2 ways to write this. This could be written like this, or it could be written with that open circle. Those 2 things mean the exact same. All right, 2 ways to write the same. That would be the same answer. All that's the same. If we wanted to go the other way around, so let's do g of f of x. Remember, that's the same notation as this. So if you have a preference, like maybe you don't like the open circle, you like it this way, fine, you can rewrite it. You just need to know that when you see the open circle, it really means this. All right, so go ahead and take the f and put it into the g. Note that these are the same. Okay, so we're going to pick up this f function and we're going to bring it over to the g function. Wherever I see an x, I am now going to replace it with all of this f. Now remember, in the g function, x is being squared. So everything that x is being squared. So when I replace it with the 2x plus 1, all of 2x plus 1 needs to get squared. So it's going to look like this. There's me taking everything from the f function, bringing it over to the g, and I'm going to replace the x that's there with what the f function is. But since the f function is a binomial, right, I want to square the whole thing. So I have to put the parentheses there. So I should do this out. That's going to get me 4x squared plus 4x plus 1. So there would be my final answer. Okay, does this kind of ring a bell? You remember doing this from way back when? I know it's been a little while. Okay, so I'm going to leave this for just a moment and then we'll come back to this idea. All right, So today we are talking about inverses. What in the heck are those? I'll explain. An inverse of a function can be found by literally, does literally have two T's? No, right? That's right. What's so cool about the inverse of two functions? The graph of a function and its inverse. This is so cool. Wait till you see this. Reflect each other over y equals x. This will make a lot more sense in a few minutes once we do a couple examples. So if we take a look at the worksheet that I gave you, on the front, it asks us to find the inverse of each function. That's our directions, find the inverse. So luckily for us, the steps are actually super easy. So let me give you how to find an inverse. Step one. I'm literally going to write a new equation where I swap the x and y. If your original happens to be written in function notation, remember that f of x is just the same thing as y. So let's just do number one together as an example as we walk through this. So number one says, here's what the original on the paper says. F of x equals negative x to the fifth. So I'm really treating f of x as just a y, right? So if you want to take a second and write it as y equals negative x to the fifth, same thing, right? So step one tells me I literally want to swap x and y with each other. So I'm going to rewrite it as x equals negative y to the fifth. So there's step one. I just rewrite the equation and I just swap x and y. That's it. It's so easy. And then your second step is now just solve for y. Get y by itself again. Okay, so if I want to get y by itself, what do you think I should do first? Say it again. I will in 1 second. I would get rid of the negative first. So let's just divide both sides by -1. So I now have negative x equals y to the fifth. And then Well, I need to undo raising it to the fifth power. So let's take it to the fifth root. So I can take the fifth root of both sides. Then orange. So instead of taking a square root, I'm going to take a fifth root of u and a fifth root of u. And look where that gets me. Fifth root of negative x equals y. I can clean this up a tiny bit. Remember that when you have a negative underneath an odd root, you can just pull the negative out. So I want to show you something. Here is the graph of the original. Y equals negative x to the fifth. That's what it looks like. So it's kind of like this snake looking thing. It goes bloop like that, right? So I just told you that the inverse is going to be reflected over the line y equals x. So let me graph y equals x so you can see what that looks like. So there's the line. It's that perfect diagonal right through the center. So when I graph the inverse, it's going to mirror this on the other side. All right, so let's see. Let me go ahead and plot in our inverse, negative fifth root of x. Negative, let me make sure I'm doing the fifth root right. There's fifth. Negative fifth root of x. Okay, ready? Oh my gosh. Let's see. So they should be reflections of each other. Oh, look at that. Isn't that neat? Huh. So if you graph an original and its inverse, they will always be an exact reflection of each other over this line y equals x. How about that? So if I had, I don't know, a question on the final exam that asked me, hey, are these two functions inverses or not? And they graph them for me. If they were not a perfect reflection over this diagonal line, the answer would be no. But if they are, then yes. So if I have the graphs of each, it's actually really easy for me to tell if they're inverses or not. Let's try another one. Okay. How about number, I don't know, 2? Let's try 2. So I'm going to write the original, but instead of writing f of x, I'm just going to start off with a y because we're just swapping those two, right? Negative x plus 3 divided by 3. Okay, so you try it. There's my original. Step 1 is literally to just replace x and y with each other. So go ahead, everybody swap x and y. Everything else stays. I'm just swapping the x and the y. I don't move signs with it or anything like that. I just switch the two letters and then solve that new equation for y. Okay, you did it? Let's see. So I'm here. I already did step one. I swapped the X and Y. Now I gotta get that Y by itself. What would you do first to try and get this Y back by itself, Luke? Yes, let's multiply both sides by 3. So that's gonna get me 3x equals negative y plus 3, right? If I just times everybody by 3. And now I'm really close. All I gotta do is minus 3 divided by a negative 1. Bless you. 3x minus 3 equals negative y. And now let's just divide everything by negative 1. So I get negative 3x plus 3. That is my inverse. By the way, to complicate things a little bit, this is kind of weird. So if you're doing function notation, so let me just, so our original looked like this. I just want you to see this notation so you know what it is if it ever pops up, which I'm sure it will at some point. So the original was literally f of x equals negative x plus 3 over 3. We just found the inverse, but when you're in function notation, we don't use y. So the inverse looks like this. We write f of x to the negative 1 power, but it's not, this is another thing that I hate about math, because that doesn't mean to the negative 1 power anymore. It means the inverse. So we found our inverse to be negative 3x plus 3. So this notation just means the inverse of f of x. Weird, I know. Yep.
The worksheet, you do not want us to write y equals. You want us to write f of x.
For your final answer?
Yeah. For the,
Oh, you can leave it as y. Okay, yeah. All right, the only other thing that I have to show you today is, well, what happens if you take a look at the back side? The back says, hey, state whether these things are inverses or not. So at a quick glance, you can't tell. I have no idea if these things are inverses or not. So one option, if I have the ability to graph them, great, but that's, you want to graph these, that's a little annoying. So there is a relatively convenient way to check if two functions are inverses of each other. Are you ready for this? It's a little wild, but let me show you. I'm going to stick it in right here. So to check, to see if two functions are inverses, first, you're going to compose them with each other. You're going to do f of g of x. If that simplifies out to just be x, that's a good sign, okay? If that simplifies to just x, keep going. If not, the answer is no. I'll say answer is immediately no. If it does simplify to x, you then need to go the other way. You need to do g of f of x and see if that also simplifies to be x. If they both do, then those two things are inverses of each other for sure. So if f of g of x equaled x, now do g of f of x and see if that also equals x? If so, yes, they are inverses. Okay, everybody ready to try one? I'm looking at number, I'm looking at number 10 is maybe a good one to start with. All right, I gotta flip the page. So let's try number 10. Okay, so they're giving me g of x equals the cube root of negative x plus 3, and f of x is 3 minus x cubed. All right, so my job is to do f of g of x, and then I'm going to switch them. So I'm going to take all of the g of x function, and I'm going to put it into the f function. So watch how this works. 3 minus, now I'm going to replace this x with all of the g function. See how I did that? I should have done it in different colors, but here's the f of x function. Oh, no, I didn't need to do that. I took all of this, the entire g of x function, and I put it in right there. So I know this looks bad, but it actually kind of works out really nicely, because when I cube a cube root, don't they just undo each other? So watch what this becomes. This is so crazy. 3 minus, when I cube a cube root, they're going to cancel each other out. So I'm now going to have just negative x plus 3. You with me so far? And now let's just distribute that negative. So I have 3 plus x minus 3. Get out of town. Look what just happened. It just simplified to be just an x. Wow. That's so cool. So now I want to try it the other way. I want to try g of f of x and make sure that that still comes out to be an x. And if it does, then these two are in fact inverses of each other. So let's try it the other way. G of f of x. So now I'm going to take all of f and put it into the g. So let's see. So I want the opposite of everything that x is going to be. So I got to replace all of that with this. 3 minus x cubed plus 3. Is that part okay how I did that? You see all those pieces? So I took everything that f was, 3 minus x cubed, and I'm coming into the g function. I'm going to replace that x with all of this. Since I have more than one piece, I want to make sure that I put it in parentheses. So I did. And now we just simplify. It looks bad at first, But, all right, I have negative all this, so that's gonna be a -3 plus x to the third, and then I have this plus 3. Look what's happening. This is so cool. So those -3 and plus 3 cancel out, and now I just have the cube root of x cubed. What? It's just x. So yes, these two things are inverses of each other. Wow. Let's try maybe number 7. I'm thinking is a good one. I don't know if this one works or doesn't work, but either way, it'll be good practice. Is everybody okay so far? All right. This takes a while to get used to. I can acknowledge that. All right, 7. So the original gives us h of x. It doesn't matter if it's an h instead of a g, same thing. 4 over x plus 3, and then we have a -2 on the side. F of x is -4 over x plus 1. It also doesn't matter which one you try first. If you try h of f or f of h, doesn't matter. So I just, by habit, I do f of. Okay, so if I'm going to try this, I'm going to take everything that h is, and I'm going to put it into the f. So this is going to look like this, -4 over all of this, which looks terrible, but hopefully it works out a little bit nicer for us. 4 over x plus 3 minus 2. Then I have a plus 1 on the side. Okay, is everybody all right with how I plugged it in? Yeah, all right, so let's see if we can make something happen out of this. So already down here, I have these 2 separate ones. I'd love to make this one fraction. And then, because I can't have fractions inside fractions, right? If I want to divide a fraction by a fraction, don't I do keep, change, flip? Remember that? You keep the numerator, you change the multiplication, you flip the denominator. But I need this to be a single fraction first. So why don't we? So that's right now 2 over 1. So why don't we multiply that by x plus 3 over x plus 3? See if we can make our lives a little bit better down here. So now I've got -4 in the numerator, and then down here, I'm going to have 4 over x plus 3. And now let's distribute that. So that's going to be a minus 2x plus 6 over x plus 3. Don't forget that plus 1 over there. Oh, you can't even see it. So right now I'm just working on getting this as one common fraction. Now let's see where I'm at. I'd have -4. Oh, where'd that negative come from? Did I put that in? Oh, it's in the f function. Okay. And then downstairs, I'm going to have 4. I'm going to have -2x. And then 4 minus 6 is going to give me a -2 over that x plus 3. Then I have a plus 1 over here. Now I at least have, I can do keep, change, flip now with that first fraction. So let's keep the numerator, -4, times the reciprocal of this. x plus 3 over the negative 2x minus 2. And then I have a plus 1 over here. But I don't know if you guys can tell, but there's no way this thing is going to cancel out and just be an x. No matter how much I keep playing with this, these things aren't just going to miraculously cancel out, and it's not just going to leave me with an x. You get what I mean, Jelly Bean? So once I reach a point where I'm like, this is never going to simplify, I can stop and just say, no, they're not inverses of each other. Nothing is canceling out. When they are inverses, just like remember in this last one that we did, things canceled out so nicely. I had cube roots being cubed. So it all just kind of falls away. Same thing over here. I was taking the cube root of an x cubed. It's got to cancel. It's got to simplify down when it's getting way too messy like this. And it's like, there's nothing I can do. The answer is just no. So just stop and say, no, not inverses. Okay, so there's my hot tip of the day. If they're gonna be inverses, things are gonna fall into place pretty easily. If it's not, and you're just like, I don't know where else I can go with this, the answer is no. Okay, so I think I have talked for plenty long enough. I actually want to pick which ones you do. Let me look at the answer key because I want to pick ones, maybe one that I know is going to work and maybe one that I know will not work. Give me a second to just look at the key and I'll tell you which ones I want you to try. Okay, let's stop this.